You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Business continuity is more than a document or a checklist. It is an organization's living capability to sustain its most critical services through disruption. At its core, continuity planning ensures that even when failures occur, customers and stakeholders can still rely on a minimum level of service. The purpose is to anticipate what could go wrong, define acceptable levels of interruption, and establish predefined plans for response. These plans must be more than theoretical. They require practice, refinement, and commitment from leadership and staff. Think of business continuity like rehearsing fire drills. The plan itself matters, but what counts most is that people know how to act when alarms sound. A well-prepared organization can absorb shocks, pivot quickly, and restore stability before disruption escalates into crisis. Without continuity, even short outages can ripple into reputational harm, financial losses, and regulatory penalties. Business continuity distinguishes itself by focusing on sustained service delivery, even during failure conditions. Rather than promising perfection, it sets a baseline of minimum acceptable performance and ensures that the organization can meet it consistently. This involves identifying which services are mission-critical and defining how they will operate in degraded or backup modes. Imagine a hospital during a power outage. While elective procedures may pause, emergency rooms and intensive care units must remain fully operational. Business continuity planning specifies how to prioritize and support these vital functions. In the digital domain, this might mean keeping core transaction systems available while secondary analytics services temporarily suspend. By clearly defining minimum service levels, continuity planning ensures resources are allocated wisely, preventing organizations from spreading themselves too thin in a crisis. Disaster recovery often sits alongside business continuity but serves a distinct role. While continuity focuses on maintaining acceptable service during disruption, disaster recovery is about restoring systems and data to full operational state after a catastrophic event. If continuity is about keeping the lights on, disaster recovery is about rebuilding the electrical grid. For example, if a cyber attack corrupts a database, continuity measures may provide read-only replicas to keep services running, but disaster recovery will rebuild the database to full write capacity. The two concepts reinforce each other. Continuity keeps the business moving, while recovery brings systems back to normal. Confusing the two can lead to gaps where organizations assume resilience exists, but have no true path to restoration. Successful strategies integrate both, ensuring there is no handoff gap between immediate survival and long-term restoration. A business impact analysis, often abbreviated as BIA, forms the foundation of continuity planning. This analysis identifies which processes are most critical, determines tolerances for downtime or data loss, and establishes the sequence in which systems must be restored. A BIA often reveals surprising dependencies. Functions assumed secondary may turn out to be essential, while highly visible activities may tolerate temporary suspension. For example, payroll processing may seem routine, but its absence can quickly erode employee trust. By systematically assessing impacts, organizations gain clarity on what truly matters and how fast it must return. The BIA also drives investment decisions, since limited resources must be directed to the highest priority functions. Much like triage in emergency medicine, the BIA ensures that life-saving services receive attention first, setting clear expectations for stakeholders about what will resume and when. Recovery Time Objective, or RTO, is one of the most widely recognized terms in continuity planning. It defines the maximum acceptable duration of service outage before business consequences become unacceptable. For example, an e-commerce site may set an RTO of 1 hour for its checkout process, recognizing that extended downtime directly translates to lost revenue. Different systems may have vastly different RTOs depending on their role. The RTO acts like a timer set at the moment of disruption, counting down to the point at which business impacts escalate from tolerable to critical. Defining realistic RTOs requires collaboration between technical teams and business leaders, since they must balance engineering feasibility with business expectations. Unrealistically short RTOs can drive excessive costs, while overly generous targets may hide vulnerabilities until too late. Establishing RTOs sharpens focus, guiding both architecture and operational preparedness. Recovery Point Objective, or RPO, complements the RTO by focusing on data rather than time. The RPO defines the maximum acceptable data loss measured backward from the point of disruption. If the RPO is 15 minutes, then the organization commits that in the event of failure, no more than 15 minutes of data will be lost. Achieving tighter RPOs often requires frequent replication or continuous journaling, while looser RPOs may suffice for less critical systems. For example, a financial trading platform might require near-zero RPO, while a marketing analytics database could tolerate daily backups. RPO expresses tolerance in human terms. How much information can we afford to lose? Balancing RTO and RPO ensures strategies address both time to recovery and data completeness. Together, they set measurable anchors for planning, testing, and validating business continuity practices. Dependency mapping is a critical exercise in continuity design. It charts the web of connections, linking applications, databases, identities, networks, and third-party services. Without this map, recovery efforts risk missing hidden bottlenecks. For instance, restoring a customer portal may fail if its authentication service is overlooked or if it relies on a vendor-hosted API that is down. Dependency mapping exposes these relationships, ensuring that continuity plans reflect real-world architecture rather than assumptions. Think of it like tracing plumbing lines in a house. Fixing one leak without understanding the connections may simply shift pressure elsewhere. Accurate dependency maps guide sequencing and restoration efforts, highlight critical choke points, and inform investment in redundancy. They also prepare organizations for cascading failures, where one outage ripples outward, affecting multiple systems in unexpected ways. Continuity strategies describe the architectural patterns organizations adopt to survive disruption. Common models include active-active, where two environments run in parallel to provide seamless failover; active-passive, where a standby environment is promoted only when primary fails; warm standby, where systems are partially provisioned and require activation; and pilot-light, where only essential components run continuously until scaled up during crisis. Each strategy balances cost, performance, and resilience differently. Active-active delivers near-instant failover but at high expense, while pilot-light minimizes cost but requires more recovery time. Selecting among them is not a purely technical choice. It reflects business priorities, budget constraints, and tolerance for risk. Much like choosing between insurance plans, each option covers the essentials but at varying levels of immediacy and expense. Organizations must weigh these carefully, guided by their BIA, RTO, and RPO targets. Data protection lies at the heart of both continuity and recovery. Without reliable backups, snapshots, and replication, continuity strategies collapse. Backups provide baseline resilience by creating retrievable copies of data. Snapshots capture system states at specific points, enabling rollback from corruption or error. Replication continuously mirrors data to alternate locations, supporting tight RPOs. Increasingly, organizations also employ immutability data copies that cannot be altered or deleted to defend against ransomware and malicious tampering. These protections act like layers of safety nets, catching different kinds of falls. Just as climbers rely on multiple ropes, carabiners, and anchors, businesses must maintain overlapping safeguards to ensure that even if one fails, others remain intact. Data protection does not guarantee uninterrupted service, but it ensures that when continuity is challenged, recovery can proceed without catastrophic loss. Runbooks transform continuity strategies from theory into executable action. These are stepwise procedures detailing how to perform failover, rollback, and validation. Well-crafted runbooks reduce ambiguity in stressful moments, by giving staff a reliable guide. Instead of improvising during a crisis, teams follow rehearsed instructions, ensuring consistency across shifts and personnel. Runbooks often include checklists, escalation paths, and verification steps. For example, a database failover runbook may specify commands, expected outputs, and validation tests before declaring success. Think of runbooks like emergency response manuals for pilots. When engines fail, the cockpit crew does not debate from scratch but follows predefined procedures. Without runbooks, continuity plans risk collapsing into confusion, leaving outcomes to chance rather than design. Communications plans are another vital component, often underestimated until tested. These plans identify stakeholders, communication channels, pre-drafted templates, and the cadence of updates during an event. When services falter, silence breeds uncertainty and panic. A structured communication plan reassures stakeholders that the situation is understood and being managed. For example, customers may receive updates every 30 minutes, while executives are briefed hourly and regulators informed as required by law. Plans also specify channels, from internal chat platforms to press releases, ensuring messages reach their audience reliably. Communication is not an afterthought, it shapes perception and trust. Much like a ship captain updating passengers during a storm, leaders must communicate steadily, even if the full resolution is still in progress. Effective communication buys patience and maintains confidence during turbulent times. Staffing and role assignments make continuity actionable. Plans designate an incident commander to coordinate response, technical leads for specific systems, and communication officers to manage messaging. This clarity avoids duplication of effort and prevents critical tasks from falling through the cracks. In many ways, it mirrors a military chain of command. Each person knows their role, responsibilities, and reporting lines. During a disruption, hesitation or confusion can magnify losses. By pre-assigning roles and rehearsing them in exercises, organizations transform continuity from paper to practice. Moreover, clear staffing reduces burnout, since responsibilities are shared and expectations established. The absence of defined roles often leads to chaos, with multiple people pulling in different directions or critical decisions delayed. Continuity thrives on discipline, and staffing frameworks provide the backbone for that discipline. Alternate work arrangements are increasingly important in a world of distributed teams and hybrid operations. Plans must ensure that employees can continue essential tasks through remote access, alternate devices, and secure collaboration platforms. For example, if headquarters becomes inaccessible due to natural disaster, staff should seamlessly switch to home offices or regional branches. Secure virtual private networks, cloud-based productivity tools, and pre-provisioned laptops form part of these arrangements. The COVID-19 pandemic underscored the necessity of such contingencies, as organizations worldwide were forced into prolonged remote operation. Alternate work planning is not simply about technology. It is about preserving organizational rhythm when physical spaces are disrupted. Ensuring secure, resilient collaboration channels maintains continuity of decision-making and execution, preventing the organization from stalling at its most vulnerable moments. Facilities and network contingencies address the physical and infrastructural underpinnings of continuity. Backup power supplies, redundant internet connections, and failover circuits keep systems alive when local facilities falter. For example, data centers often employ uninterruptible power supplies coupled with generators to ride out utility failures. Network diversity, using multiple carriers and paths protects against localized outages. These measures reflect an understanding that digital resilience rests upon physical resilience. Much like a high-performance car depends not only on the engine but also on the quality of its tires and fuel, continuity depends on robust infrastructure. Testing these contingencies is crucial, as unused generators and failover circuits often fail when finally needed. Facilities planning ensures that continuity strategies are not undermined by overlooked basics such as electricity and connectivity. Vendor and contract dependencies add another layer of complexity. Many modern services rely on third-party providers for infrastructure, applications, or specialized functions. Continuity planning requires cataloging these dependencies, recording service-level agreements, contacts, and escalation paths. During a disruption, the ability to reach a vendor quickly, confirm their recovery commitments, and escalate appropriately may determine the speed of restoration. For example, a payment processor outage might halt e-commerce entirely unless fallback options exist. Documenting these dependencies prevents organizations from being blindsided during crises. It is much like relying on subcontractors in construction. Success depends not just on your own plan, but also on the readiness and reliability of your partners. Strong vendor continuity agreements extend resilience beyond organizational walls, ensuring the entire service chain holds under pressure. Compliance and insurance considerations round out continuity planning. Regulations often dictate minimum standards for resilience, such as mandatory RTOs for financial transactions or reporting timelines for healthcare outages. Insurance policies may also provide financial coverage for business interruption, but only if the organization can demonstrate compliance with specified continuity measures. Thus, documentation of obligations, coverages, and reporting requirements becomes essential. Compliance ensures that continuity practices meet external expectations, while insurance provides financial backstops when preventative measures fail. It is analogous to driving with both a seatbelt and car insurance. The seatbelt reduces risk, while the insurance mitigates cost if an accident still occurs. Addressing these considerations ensures continuity planning is not only operationally sound, but also legally and financially defensible. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Failover orchestration is the coordinated process of switching services from a primary environment to an alternate one during disruption. This sequence typically includes traffic steering, promotion of standby systems to active status, and data cutover, all governed by guardrails to minimize risk. The orchestration must be scripted and tested so that handoffs occur smoothly rather than chaotically. For example, rerouting web traffic to a secondary data center is not just a single action. It must align with database replication status, application version control, and network availability. If any step is skipped, continuity may collapse into inconsistency or data loss. Think of orchestration like a conductor leading a symphony. Instruments must enter in the correct order at the correct time. Without orchestration, failover is little more than improvisation, raising the risk of partial recovery, cascading failures, or extended downtime. The domain name system, or DNS, plays a pivotal role in failover strategies because it directs user requests to the correct service endpoint. DNS-based continuity approaches use health checks, weighted records, and geo-policies to redirect traffic automatically. For example, if a primary server fails its health check, DNS can shift new connections to a standby environment. Weighted records allow gradual traffic balancing during recovery, while geo-policies route users to the nearest healthy region. However, DNS has propagation delays, meaning changes may take minutes to reach all users, depending on cache settings. This lag must be factored into planning. DNS continuity resembles highway detour signage. When one path closes, drivers are guided to alternate routes. The signage must be accurate, timely, and visible, or travelers may still end up stranded. Properly configured DNS strategies ensure resilience at the very gateway of user access. Capacity headroom is the intentional reservation of compute, storage, and license quotas to absorb sudden failover loads. Without this buffer, backup environments may collapse under unexpected demand the moment they are activated. For example, if an e-commerce site doubles traffic during holiday sales, a standby region must be sized to handle not just average loads, but peak scenarios. Neglecting capacity headroom is like having a spare tire but forgetting to inflate it. The backup exists but is unusable when needed. Effective headroom planning requires monitoring current usage, forecasting growth, and regularly stress testing standby environments. Cloud elasticity can mitigate some of these challenges by scaling on demand, but licensing, database capacity, and external integrations may still impose limits. Ensuring adequate headroom transforms theoretical continuity into practical readiness, preventing a secondary crisis triggered by the very act of failing over. Configuration parity ensures that standby environments mirror production systems closely enough to be trustworthy. This includes infrastructure baselines, application versions, security patches, and secret stores such as encryption keys and certificates. Without parity, failover may succeed technically but fail functionally, with users encountering unexpected errors or degraded services. Imagine replacing a broken car with a spare only to find it has a different transmission, usable, perhaps, but not suited to the journey. Parity is best maintained through automation pipelines that continuously apply production configurations to standby systems. Infrastructure as code plays a crucial role here, enforcing consistency across environments. Secret synchronization must also be secured, since stale credentials can derail continuity at the worst moment. Configuration parity ensures that recovery is not just fast but also accurate, delivering the same service quality customers expect under normal operations. Integrity checks act as the final verification before declaring a failover successful. These checks confirm that data is intact, applications are the correct versions, and configurations match expectations. Without integrity validation, an organization may prematurely announce recovery, only to discover hidden corruption or misalignment later. Integrity checks can include automated database queries, checksum verifications, user transaction tests, and security control confirmations. Think of it like a pilot's landing checklist. Touchdown may feel complete, but until brakes, flaps, and instruments are checked, the flight is not truly safe. Integrity checks protect against the false sense of security that can arise from partial recovery. They provide assurance to both technical teams and business leaders that systems are not merely online but trustworthy, reducing the risk of cascading issues following disruption. Exercises are the proving ground of business continuity. These structured tests come in three main forms: tabletop, functional, and full-scale. Tabletop exercises are discussion-based, walking teams through scenarios without system disruption. Functional exercises test specific components, such as restoring a database. Full-scale exercises simulate real outages, including failover and user impact. Each type has value, with tabletop sessions refining plans and full-scale drills validating execution under pressure. Documented objectives ensure that exercises measure meaningful outcomes rather than serving as symbolic rituals. For example, a full-scale test might measure whether a critical service can fail over within its RTO while maintaining data integrity. Exercises are like rehearsals for a play. They reveal weak lines, missed cues, and unprepared actors before the live performance. Organizations that test thoroughly discover gaps early, when stakes are low, rather than during genuine crises. Chaos experiments push resilience further by deliberately injecting controlled failures into systems. These tests go beyond rehearsals by breaking things on purpose to uncover hidden dependencies and brittle points. For instance, intentionally disabling a network link can reveal whether services reroute automatically or whether unnoticed bottlenecks exist. Chaos engineering is not recklessness. It is structured exploration designed to validate that systems can withstand disruption gracefully. Think of it as training firefighters by setting controlled burns, ensuring they are ready for real wildfires. Such experiments build confidence that continuity strategies are robust not only on paper, but also under unpredictable conditions. By normalizing failure as a learning tool, chaos experiments help organizations evolve from reactive recovery to proactive resilience. They turn uncertainty into a manageable and testable aspect of continuity planning. Evidence collection ensures that both exercises and real events leave a traceable record of what occurred. Timelines, metrics, decision logs, and artifacts must be documented to provide lessons learned and satisfy regulatory audits. Evidence demonstrates that continuity plans were not just followed, but measured against defined objectives like RTO and RPO. For example, logs may show that failover completed in 17 minutes against a 30-minute target, or that 10 seconds of data loss occurred against a 60-second RPO. This evidence is like a game replay, allowing coaches to study what went right and what went wrong. Without it, continuity efforts risk becoming anecdotal, leaving no foundation for accountability or improvement. Evidence collection also validates insurance claims, regulatory reporting, and executive briefings, turning chaotic moments into structured, analyzable learning opportunities. Post-exercise reviews transform evidence into actionable improvements. These reviews capture findings, assign ownership, set due dates, and establish verification criteria. They prevent lessons from fading once normal operations resume. A key part of reviews is candid reflection: what went as expected, what surprised the team, and what must change. For example, a review may reveal that communication templates were outdated or that DNS propagation took longer than planned. By assigning ownership and deadlines, reviews ensure accountability rather than leaving improvements to chance. This process is much like post-game analysis in sports teams' replay events, highlight errors, and plan drills to strengthen weak areas. Post-exercise reviews complete the feedback loop, embedding resilience into the organization's culture rather than treating continuity as a one-time event. Regional and jurisdictional constraints add complexity to multi-region continuity designs. Data residency laws may require certain information to stay within specific borders, while latency concerns may shape where backups are hosted. For example, European privacy regulations often prevent data from being replicated to regions outside the EU. These constraints can limit design options, forcing trade-offs between compliance, performance, and cost. Continuity planners must navigate this landscape carefully, ensuring failover strategies respect both legal mandates and user experience expectations. It is similar to building an airline route map. Not all airports are available, and some paths are restricted. Careful design prevents continuity strategies from unintentionally violating laws or degrading service quality. Regional considerations remind organizations that resilience is as much about governance and geography as it is about technology. Third-party continuity validation ensures that vendors and partners are not weak links in the chain. Organizations often depend on external providers for services ranging from payment processing to cloud hosting. Validating their continuity involves obtaining attestations, reviewing test results, and understanding fallback options. For example, a SaaS provider should provide evidence of regular disaster recovery tests and RTO guarantees. Without validation, organizations may assume resilience that does not exist, only to discover vendor failures during crisis. This is akin to assuming your neighbor's fire alarm works without ever hearing it tested. Vendor validation adds external assurance that the resilience of the whole ecosystem aligns with organizational needs. Strong vendor partnerships extend continuity planning beyond internal walls, acknowledging the interconnected realities of modern digital services. Cost-risk trade-offs shape every continuity decision. High availability across multiple regions delivers robust resilience but at significant expense. Conversely, relying on a single backup tape may be cheap but exposes the business to catastrophic risk. Organizations must weigh redundancy, performance, and budget against their tolerance for downtime and data loss. This calculus is guided by BIA findings and stakeholder priorities. Much like purchasing insurance, continuity investments balance peace of mind against financial feasibility. Leaders must recognize that perfection is unattainable, but negligence is unacceptable. By framing continuity decisions as explicit trade-offs, organizations avoid both complacency and over-engineering. This balance ensures that resilience is sustainable over time, rather than a one-time expenditure that strains budgets and erodes support. Monitoring alignment ties continuity strategies to real-time operational health. Service level indicators, or SLIs, such as latency, error rates, and throughput provide measurable signals that continuity objectives are being met. Alert thresholds ensure that deviations trigger timely responses before disruptions escalate. For instance, rising latency in a replicated database may indicate replication lag that threatens RPO compliance. Monitoring is like a heartbeat monitor for resilience. It provides early warning of stress, enabling intervention before collapse. Alignment between continuity goals and monitoring ensures that technical metrics translate into meaningful business outcomes. Without it, continuity strategies risk drifting into irrelevance, with teams measuring activity but not impact. Effective monitoring bridges planning and operations, keeping continuity goals alive in day-to-day performance management. Anti-patterns represent continuity practices that consistently fail in practice. Examples include untested runbooks that collapse under real stress, single-region dependence that magnifies risk, and manual-only failovers that cannot keep pace with modern demands. These anti-patterns often arise from overconfidence, cost-cutting, or neglect. They are comparable to common health pitfalls: skipping exercise, ignoring symptoms, or relying solely on willpower without preparation. Recognizing anti-patterns allows organizations to confront them directly, replacing them with tested, automated, and distributed strategies. By naming the failures to avoid, continuity programs protect themselves against complacency. Highlighting anti-patterns reinforces the idea that resilience requires continual vigilance and that shortcuts often create vulnerabilities far greater than the effort saved in the moment. From an exam perspective, candidates must be able to select appropriate failover patterns, identify essential runbook components, and evaluate the rigor of continuity exercises. Exam questions often probe whether learners can connect technical practices like DNS rerouting or chaos testing to business goals such as meeting RTO and RPO. Success depends not just on memorizing definitions, but on reasoning about scenarios. For example, which failover strategy balances cost and recovery speed for a regulated healthcare provider? Understanding trade-offs and aligning them to business priorities demonstrates true mastery. Exam relevance highlights that continuity is not an abstract theory. It is a structured discipline that balances planning, testing, and execution to achieve measurable outcomes under stress. This reinforces continuity as both a technical and organizational competency. In summary, practiced failover, current runbooks, and measurable exercises transform continuity planning from a static document into dependable outcomes during real disruptions. Continuity thrives on orchestration, configuration parity, and integrity checks, all tied together by monitoring and metrics. Exercises and chaos experiments ensure strategies are not only written but lived, while post-exercise reviews embed learning into culture. Vendor validation, jurisdictional awareness, and cost-risk balancing acknowledge the broader ecosystem and constraints in which resilience operates. By recognizing anti-patterns and emphasizing evidence collection, organizations keep continuity grounded in reality rather than assumptions. Ultimately, continuity is not about avoiding all disruptions. It is about ensuring that when disruptions occur, critical services endure, trust is preserved, and recovery unfolds with discipline and confidence. This holistic approach enables organizations to sustain resilience in an unpredictable world. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.